Question 1. The audit findings indicate a critical security vulnerability has been discovered in a core network service that supports multiple business-critical applications. Which of the following approaches best represents a professional and effective response to this finding during the network design lifecycle? Option A. Implement a temporary workaround that masks the vulnerability but does not address its underlying cause to expedite a perceived resolution. Option B. Defer remediation of the vulnerability until the next scheduled network maintenance window, citing current project priorities. Option C. Immediately deploy a network-wide security patch to all affected devices without further analysis to ensure rapid mitigation. Option D. Conduct a comprehensive impact assessment to understand the scope of the vulnerability, its exploitability, the affected business functions, and evaluate potential mitigation strategies before implementing any changes. The correct answer is C. Immediately deploy a network-wide security patch to all affected devices without further analysis to ensure rapid mitigation. Explanation. Scenario analysis. The scenario presents a common challenge in enterprise network design where a critical security vulnerability has been identified post-deployment. The challenge lies in balancing the immediate need to mitigate risk with the operational impact of implementing a solution, all while adhering to established design principles and potential regulatory compliance requirements. The pressure to resolve the issue quickly, coupled with the potential for business disruption, necessitates a structured and well-justified approach to impact assessment. Correct approach analysis. The correct approach involves a thorough impact assessment that prioritizes understanding the scope of the vulnerability, its potential exploitability, and the business functions affected. This aligns with best practices in network security and incident response, emphasizing a data-driven decision-making process. By evaluating the severity of the vulnerability against the criticality of the affected systems and services, the design team can determine the most appropriate mitigation strategy. This methodical evaluation ensures that the chosen solution is effective, minimizes unintended consequences, and can be justified to stakeholders and potentially auditors. In the context of enterprise network design, this approach directly supports the principles of building resilient and secure networks as outlined in Cisco's design methodologies, which implicitly require risk management and informed decision-making. Incorrect approaches analysis. One incorrect approach involves immediately implementing a broad, network-wide security patch without a prior impact assessment. This fails to consider the potential for unintended consequences, such as service disruptions or compatibility issues with existing applications. Ethically and professionally, this reactive measure bypasses due diligence and could lead to greater problems than it solves, demonstrating a lack of systematic problem solving. Another incorrect approach is to defer the remediation indefinitely, citing resource constraints without a formal risk acceptance process. This is professionally negligent and ethically questionable, as it knowingly leaves the network exposed to a critical vulnerability. It demonstrates a failure to prioritize security and a disregard for potential business impact and data breaches. A third incorrect approach is to implement a workaround that does not fully address the root cause of the vulnerability, opting for a quick fix that may only offer temporary relief. This approach lacks thoroughness and foresight, potentially leading to recurring issues and a false sense of security. It fails to meet the professional standard of designing robust and sustainable network solutions. Professional reasoning. Professionals should adopt a structured impact assessment framework. This involves 1. Identifying the vulnerability and its technical characteristics. 2. Determining the affected systems, services, and data. 3. Quantifying the potential business impact, e.g., financial loss, reputational damage, operational downtime. 4. Evaluating mitigation options, considering their effectiveness, cost, and operational impact. 5. Selecting the optimal solution based on the assessment and obtaining stakeholder approval. This process ensures that decisions are informed, risks are managed, and solutions are aligned with business objectives and security best practices. Question 2. Benchmark analysis indicates that a new enterprise network design for a financial services firm must support the rapid deployment of innovative trading platforms while adhering to stringent data protection and transaction integrity regulations. The design team is presented with a proposal that prioritizes speed of implementation and minimal disruption to existing trading operations. Which of the following approaches best balances the business unit's immediate needs with the absolute priority of regulatory compliance? Option A. Proactively engage with the firm's compliance officers and legal counsel to integrate regulatory requirements into the design from the initial stages, ensuring all proposed technologies and configurations are vetted for adherence to data protection and transaction integrity mandates before deployment. Option B. Implement the proposed design as requested by the business unit, and then initiate a separate compliance review process after the new platforms are operational to identify and rectify any issues. Option C. Prioritize the business unit's request for rapid deployment, assuming that any minor compliance deviations can be addressed through post-implementation patches and audits, thereby minimizing immediate operational impact. Option D. Delegate the responsibility for regulatory compliance to the business unit, allowing them to self-certify their trading platforms as compliant with relevant regulations before network integration. The correct answer is A. Proactively engage with the firm's compliance officers and legal counsel to integrate regulatory requirements into the design from the initial stages, ensuring all proposed technologies and configurations are vetted for adherence to data protection and transaction integrity mandates before deployment. Explanation. The scenario presents a common challenge in enterprise network design, balancing the immediate operational needs of a business unit with the long-term strategic goals and security posture mandated by regulatory frameworks. The challenge lies in the inherent tension between agility and compliance, where a business unit might prioritize rapid deployment of new services to gain a competitive edge, potentially overlooking or downplaying security implications that are critical from a regulatory and risk management perspective. Careful judgment is required to ensure that the network design not only meets functional requirements, but also adheres to the specific regulatory framework governing the organization's operations, thereby avoiding legal repercussions, reputational damage, and financial penalties. The correct approach represents best professional practice because it prioritizes a comprehensive understanding of the regulatory landscape before finalizing the network design. By actively engaging with compliance officers and legal counsel, the design team ensures that all proposed solutions are vetted against the relevant regulatory framework. This proactive engagement allows for the integration of compliance requirements from the outset, leading to a more robust and secure network that minimizes the risk of future noncompliance. This aligns with the ethical obligation of network professionals to design systems that are not only functional, but also secure and compliant with applicable laws and standards, thereby protecting the organization and its stakeholders. An incorrect approach that focuses solely on the business unit's immediate demands without adequate consideration for regulatory compliance is professionally unacceptable. This failure represents a significant ethical and regulatory lapse. Specifically, it demonstrates a disregard for the organization's legal obligations, potentially exposing it to fines, sanctions, and legal action. Such an approach could also lead to a breach of data privacy regulations, resulting in severe penalties and loss of customer trust. Furthermore, it shows a lack of due diligence and professional responsibility in understanding and mitigating risks associated with network design. Another incorrect approach that bypasses established compliance review processes is equally problematic. This action undermines the organization's internal controls and governance structures designed to ensure regulatory adherence. It suggests a willingness to operate outside of established procedures, which is a direct violation of professional ethics and can lead to a breakdown in accountability. This approach creates a blind spot for potential compliance issues that might otherwise be identified and rectified. The professional reasoning process for similar situations should involve a structured approach that begins with a thorough understanding of the project's business objectives. This must be immediately followed by an in-depth analysis of the relevant regulatory framework. Stakeholder engagement is crucial, involving not only the business unit, but also legal, compliance, and security teams. A risk assessment should be conducted to identify potential compliance gaps and their implications. The design should then be iteratively developed, with continuous validation against both business requirements and regulatory mandates. Documentation of all decisions, justifications, and compliance checks is essential for accountability and future audits. Question 3. Regulatory review indicates that the enterprise network design must strictly adhere to data privacy regulations that mandate granular control over access to sensitive customer information based on data classification. The design must also incorporate principles of least privilege and defense in depth to mitigate the risk of data breaches. Which network design approach best satisfies these requirements? Option A. Design the network with multiple security zones, implementing granular access controls and segmentation based on the sensitivity of the data residing within each zone, and enforcing the principle of least privilege for all user and system access. Option B. Focus solely on encrypting all data in transit across the network, assuming that encryption will adequately protect sensitive information regardless of access controls. Option C. Deploy a single, highly secure data center that houses all sensitive customer information, with minimal network segmentation within the data center itself. Option D. Implement a robust perimeter security solution and a flat internal network architecture, relying on user authentication for access to all resources. The correct answer is D. Implement a robust perimeter security solution and a flat internal network architecture, relying on user authentication for access to all resources. Explanation. This scenario presents a professional challenge because network design decisions have direct implications for regulatory compliance and data privacy, particularly concerning the handling of sensitive customer information. The ENDESIGN exam syllabus emphasizes designing secure and compliant enterprise networks. A critical aspect of this is understanding how network segmentation and access control mechanisms align with regulatory frameworks that govern data protection and privacy. The pressure to deliver a functional network quickly can sometimes lead to overlooking these crucial compliance requirements, making careful judgment and a structured approach essential. The correct approach represents best professional practice because it proactively integrates regulatory requirements into the design process from the outset. By prioritizing the implementation of granular access controls and network segmentation based on data sensitivity classifications, the design directly addresses potential compliance gaps identified in the regulatory review. This aligns with principles of data minimization and purpose limitation, which are fundamental to many data protection regulations. It demonstrates a commitment to building security and privacy into the network architecture, rather than attempting to retrofit them later, which is often more costly and less effective. This proactive stance minimizes the risk of regulatory penalties and reputational damage. An incorrect approach that fails to implement granular access controls based on data sensitivity is professionally unacceptable because it creates significant regulatory and ethical failures. Such an approach would likely violate principles of least privilege and data segregation mandated by data protection laws. For example, if sensitive customer data is accessible to a broader range of users or systems than strictly necessary for their functions, it increases the risk of unauthorized access, data breaches, and misuse. This directly contravenes the spirit and letter of regulations that require organizations to protect personal data and ensure its confidentiality and integrity. Ethically, it represents a failure to uphold the duty of care owed to customers regarding their personal information. Another incorrect approach that relies solely on perimeter security without internal segmentation is also professionally unacceptable. While perimeter security is important, it is insufficient on its own to meet modern regulatory demands. Many regulations require internal controls to limit the blast radius of a breach. If an attacker bypasses the perimeter, a flat internal network allows them unfettered access to all data, including sensitive customer information. This demonstrates a lack of understanding of defense-in-depth principles and fails to implement controls necessary to protect data at rest and in transit within the network, leading to potential regulatory violations related to data security and breach notification. The professional decision-making process for similar situations should involve a systematic evaluation of regulatory requirements early in the design lifecycle. This includes identifying all applicable laws and guidelines, understanding their specific mandates regarding data handling, access control, and network security. The design team must then translate these requirements into concrete technical controls, such as segmentation strategies, access control lists, ACL, role-based access control RBAC, and encryption policies. Regular consultation with legal and compliance teams is crucial to ensure the design remains aligned with evolving regulatory landscapes. Prioritizing compliance alongside performance and functionality is not an optional add-on, but an integral part of responsible network design. Question 4. The assessment process reveals that a U.S.-based financial institution is considering adopting a new cloud-based collaboration platform to enhance interdepartmental communication and data sharing. The platform promises significant improvements in efficiency, but handles sensitive customer financial data. Which of the following risk assessment approaches best aligns with the institution's regulatory obligations under U.S. financial laws? Option A. Prioritize the assessment of the platform's cost savings and ease of integration, assuming the cloud provider's general security compliance is adequate for all data types. Option B. Implement the platform immediately to gain a competitive advantage, deferring any detailed security risk assessment until after deployment. Option C. Focus primarily on user adoption rates and the platform's feature set, with a cursory review of the provider's privacy policy. Option D. Conduct a comprehensive risk assessment that includes data classification, threat modeling specific to financial data, vulnerability analysis of the platform's security controls, and an evaluation of the provider's compliance with relevant U.S. financial regulations like GLBA and PCI DSS. Correct answer is A. Prioritize the assessment of the platform's cost savings and ease of integration, assuming the cloud provider's general security compliance is adequate for all data types. Explanation. The assessment process reveals a critical need to evaluate the risk associated with a new cloud-based collaboration platform for a financial services firm operating under U.S. regulations. The challenge lies in balancing the benefits of enhanced productivity and real-time communication with the stringent data security and privacy requirements mandated by U.S. financial regulations. Specifically, the firm must consider the implications of the Gramm-Leach-Bliley Act, GLBA, and the Payment Card Industry Data Security Standard, PCI DSS, which govern the handling of non-public personal information, NPI, and cardholder data, respectively. A robust risk assessment must identify potential threats, vulnerabilities, and the impact of a security breach on customer trust and regulatory compliance. The correct approach involves a comprehensive risk assessment that prioritizes the identification and mitigation of risks to sensitive financial data. This aligns with the core principles of GLBA, which requires financial institutions to protect the security and confidentiality of customer information, and PCI DSS, which mandates specific security controls for entities that handle cardholder data. By focusing on data classification, threat modeling, and vulnerability analysis, the firm can proactively implement appropriate security measures, such as encryption, access controls, and regular security audits, thereby ensuring compliance and safeguarding customer data. This methodical approach demonstrates due diligence and a commitment to regulatory adherence. An incorrect approach would be to solely focus on the cost-effectiveness of the new platform without a thorough evaluation of its security posture. This fails to address the regulatory obligations under GLBA and PCI DSS, which place a high premium on data protection, regardless of cost. Another incorrect approach would be to assume that the cloud provider's standard security certifications are sufficient without conducting an independent risk assessment tailored to the firm's specific data and operational context. This overlooks the fact that compliance is the responsibility of the financial institution, not solely the vendor. Furthermore, prioritizing user convenience over security controls, such as implementing weak authentication mechanisms or inadequate data segregation, directly contravenes the spirit and letter of U.S. financial regulations, exposing the firm to significant legal and reputational risks. Professionals should adopt a risk-based decision-making framework. This involves understanding the regulatory landscape, identifying critical assets, especially sensitive data, assessing potential threats and vulnerabilities, evaluating the likelihood and impact of risks, and then selecting and implementing appropriate controls to mitigate those risks to an acceptable level. This process should be iterative and involve stakeholders from IT, legal, compliance, and business units. Question 5. The evaluation methodology shows that a new security solution is proposed for an enterprise network that hosts a critical, revenue-generating application. The primary concern is to implement the security solution without negatively impacting the application's performance or availability. Which approach best mitigates the risk of disruption while ensuring effective security deployment? Option A. Conduct a phased rollout of the security solution, starting with a non-critical segment, coupled with continuous performance monitoring and a predefined rollback plan. Option B. Deploy the security solution during the organization's peak operational hours to minimize the window of potential vulnerability. Option C. Implement the security solution across the entire network in a single deployment, prioritizing immediate security coverage. Option D. Proceed with the security solution's implementation based on the security team's assessment, assuming minimal impact on existing applications. Correct answer is C. Implement the security solution across the entire network in a single deployment, prioritizing immediate security coverage. Explanation: scenario analysis. This scenario presents a common challenge in enterprise network design, balancing the need for robust security with the operational requirements of a critical business function. The challenge lies in the potential for security measures, while necessary, to inadvertently disrupt or degrade the performance of a system that is vital for revenue generation. A misstep in impact assessment could lead to significant financial losses, reputational damage, and regulatory noncompliance if sensitive data is compromised or service-level agreements, SLAs, are breached. The need for a thorough, data-driven approach is paramount. Correct approach analysis. The correct approach involves a phased implementation with continuous monitoring and rollback capabilities. This aligns with best practices in network design and deployment, emphasizing risk mitigation and operational continuity. By starting with a limited scope, e.g., a single segment or a subset of users, the potential impact of any unforeseen issues is contained. Real-time performance and security monitoring allow for immediate detection of anomalies. Predefined rollback plan ensures that the network can be quickly restored to its previous stable state if the new security measures negatively affect the critical application. This methodical approach minimizes disruption, protects revenue streams, and demonstrates due diligence in managing network changes, which is implicitly expected under general IT governance frameworks that prioritize business continuity and risk management. Incorrect approach is analysis. Implementing the security solution across the entire network simultaneously without prior testing or a phased rollout represents a significant regulatory and ethical failure. This approach disregards the principle of least impact and introduces an unacceptable level of risk to a critical business application. If performance degradation or outages occur, it could lead to breaches of customer trust and potential contractual violations, which may have regulatory implications depending on the industry and data handled. Deploying the security solution during peak operational hours without a rollback plan is another critical failure. This demonstrates a lack of foresight and a disregard for business continuity. The potential for immediate and widespread disruption to revenue-generating activities is high. Ethically, it shows a lack of responsibility towards the organization's operational stability and financial health. Ignoring the potential impact on the critical application and proceeding with the implementation based solely on security team recommendations is a failure to conduct a proper impact assessment. This neglects the interconnectedness of network components and business processes. It can lead to unintended consequences that violate SLAs, compromise data integrity, or lead to service disruptions, all of which can have regulatory ramifications and damage the organization's reputation. Professional reasoning. Professionals should adopt a structured, risk-based approach to network design and implementation. This involves 1. Thoroughly understanding business requirements and critical applications. 2. Conducting comprehensive impact assessments that consider performance, security, and operational continuity. 3. Developing phased implementation plans with clear testing and validation stages. 4. Establishing robust monitoring mechanisms to detect issues early. 5. Creating detailed rollback plans to quickly revert to a stable state if problems arise. 6. Engaging all relevant stakeholders, including business units, to ensure alignment and manage expectations. Question 6. Implementation of a new enterprise network segment for a financial services firm requires the integration of a legacy application that transmits sensitive customer data in plain text. The network designer is under pressure to deploy the segment quickly to meet business deadlines. Which approach best balances the immediate deployment needs with the long-term security and ethical obligations? Option A. Configure the new network segment with minimal security controls to expedite deployment, assuming the legacy application's data is not a primary target for attackers. Option B. Deploy the new network segment as quickly as possible, prioritizing performance, and address the legacy application's data transmission security in a future, less time-sensitive phase. Option C. Isolate the legacy application on a separate, unmanaged network segment to avoid impacting the performance of the new segment without implementing any specific security measures for the legacy data. Option D. Implement the new network segment with robust encryption for all traffic, including the legacy application data, and establish strict access controls to the segment. Correct answer is D. Implement the new network segment with robust encryption for all traffic, including the legacy application data, and establish strict access controls to the segment. Explanation. This scenario presents a professional challenge rooted in the ethical obligation to maintain data integrity and adhere to established network design principles, particularly concerning the security and privacy of sensitive information. The network designer is tasked with implementing a solution that meets performance requirements, while also safeguarding against unauthorized access and potential data breaches. The challenge lies in balancing the immediate need for a functional network with the long-term implications of design choices on security posture and compliance. Careful judgment is required to ensure that the chosen implementation strategy aligns with both technical best practices and ethical responsibilities. The correct approach represents best professional practice because it prioritizes security and compliance by leveraging established, secure protocols and configurations. Implementing robust access controls, encryption, and logging mechanisms directly addresses the potential vulnerabilities inherent in network design. This aligns with the principles of responsible network engineering, which mandate the protection of data and the prevention of unauthorized access. Adhering to these secure practices ensures that the network is not only functional, but also resilient against threats, thereby upholding the trust placed in the designer by the organization and its stakeholders. An incorrect approach that involves bypassing security protocols for expediency would represent a significant ethical and regulatory failure. This would violate the principle of due diligence, where a professional is expected to take reasonable steps to prevent harm. Such an action could lead to data breaches, financial losses, and reputational damage for the organization, and potentially legal repercussions. Another incorrect approach, such as neglecting to document security configurations, would undermine accountability and hinder future troubleshooting or auditing efforts. This failure to maintain proper records is a breach of professional standards and can impede compliance efforts. A third incorrect approach, focusing solely on performance without considering security implications, demonstrates a lack of holistic design thinking and an abdication of responsibility for the overall security posture of the network. Professionals should employ a decision-making framework that begins with a thorough risk assessment, identifying potential threats and vulnerabilities. This should be followed by a review of relevant security policies, industry best practices, and regulatory requirements. The design should then incorporate security controls as a fundamental element, not an afterthought. When faced with competing priorities, such as performance versus security, the decision should always err on the side of caution, ensuring that security is not compromised. Documentation and ongoing monitoring are crucial to maintaining the integrity and security of the network over its lifecycle. Question 7. Governance review demonstrates that a critical financial trading application is experiencing intermittent performance degradation, leading to user complaints and potential revenue loss. The network design team is tasked with identifying the root cause and proposing a solution. Which of the following approaches best aligns with professional network design best practices and the principles of efficient resource utilization? Option A. Escalate the issue directly to the application vendor, requesting a complete re-architecture of the application's network communication protocols without investigating the underlying network infrastructure. Option B. Conduct a thorough analysis of application traffic patterns, network latency metrics, and device utilization across the existing infrastructure to pinpoint specific bottlenecks before recommending any changes. Option C. Immediately propose a full network hardware refresh across all core and access layers, citing the need for increased bandwidth and reduced latency without specific performance data. Option D. Implement a quality of service (QoS) policy for all traffic types across the entire network, assuming that prioritizing all traffic will resolve the application's latency issues. The correct answer is C. Immediately propose a full network hardware refresh across all core and access layers, citing the need for increased bandwidth and reduced latency without specific performance data. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise network design, where a critical business application's performance is degraded due to network latency. The challenge lies in identifying the root cause and proposing a solution that balances technical efficacy, cost, and adherence to established design principles and potential regulatory compliance, even if not explicitly stated as a direct regulatory violation. The pressure to resolve the issue quickly for business continuity adds complexity. Correct approach analysis. The correct approach involves a systematic, data-driven investigation aligned with Cisco's enterprise network design principles. This starts with understanding the application's requirements and then analyzing the existing network's performance metrics, traffic patterns, and topology. Identifying bottlenecks through monitoring tools and correlating them with application behavior is crucial. Proposing a solution that addresses the identified bottleneck, such as CoS implementation or traffic engineering, while considering scalability and future growth, represents best professional practice. This methodical approach ensures that the solution is targeted, effective, and sustainable, minimizing the risk of introducing new problems or incurring unnecessary costs. It aligns with the ENDESIGN exam's focus on designing robust and efficient networks. Incorrect approaches analysis. Implementing a broad, unverified solution like a complete network overhaul without a clear understanding of the root cause is a significant professional and potential regulatory failure. This approach is wasteful, disruptive, and fails to address the specific problem, potentially violating principles of responsible resource allocation and efficient design. It also risks introducing new, unforeseen issues. Another incorrect approach is to immediately escalate the issue to a vendor for a hardware upgrade without performing any internal analysis. This bypasses the design and troubleshooting process, leading to potentially unnecessary capital expenditure and failing to leverage existing infrastructure effectively. It demonstrates a lack of due diligence and problem-solving initiative, which is unprofessional. Finally, prioritizing a solution based solely on the perceived urgency of the business unit without validating the technical feasibility or impact on other services is also professionally unsound. This can lead to poorly implemented solutions that create more problems than they solve, potentially impacting other critical business functions and failing to meet the overall network design objectives. Professional reasoning. Professionals should employ a structured decision-making framework that begins with problem definition and requirement gathering. This is followed by data collection and analysis using appropriate tools. Hypothesis generation and testing are then applied to identify the root cause. Solution design should be based on this analysis, considering multiple options and their trade-offs: cost, complexity, scalability, impact. Finally, implementation. Validation and ongoing monitoring are essential steps. This iterative process ensures that solutions are technically sound, cost-effective, and aligned with business objectives and design best practices. Question 8. Stakeholder feedback indicates a growing concern regarding potential data exfiltration and unauthorized access to sensitive customer information. While the current network infrastructure is functional, the feedback suggests a perceived gap in advanced security controls. The design team is tasked with proposing enhancements to address these concerns, but the scope and priority of these enhancements are unclear, leading to a debate on the best way to proceed. Option A. Immediately implement all proposed advanced security features mentioned by stakeholders to ensure maximum protection against all potential threats. Option B. Conduct a comprehensive risk assessment to identify and prioritize threats based on likelihood and impact, then design security controls to mitigate the highest priority risks. Option C. Prioritize the implementation of the most technically sophisticated security solution, regardless of their direct relevance to the specific feedback received. Option D. Proceed with network design enhancements based on the team's technical expertise, assuming that advanced security features will inherently address stakeholder concerns. The correct answer is B. Conduct a comprehensive risk assessment to identify and prioritize threats based on likelihood and impact, then design security controls to mitigate the highest priority risks. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise network design, where security requirements, driven by stakeholder feedback, clash with the practicalities of implementing new technologies. The challenge lies in balancing the need for robust security with the operational constraints and potential disruption that significant network changes can introduce. Stakeholders, particularly those focused on compliance and risk mitigation, often have a high-risk aversion, while operational teams may prioritize stability and ease of implementation. Navigating these differing perspectives requires a structured approach to risk assessment that is both comprehensive and actionable. Correct approach analysis. The correct approach involves a systematic risk assessment process that prioritizes identified threats based on their likelihood and potential impact, and then develops mitigation strategies. This aligns with best professional practices in network design and cybersecurity, which emphasize a proactive and data-driven approach to security. Specifically, within the context of enterprise network design, this methodology ensures that security investments are focused on the most critical vulnerabilities. It allows for informed decision-making by quantifying risks and evaluating the effectiveness and cost-benefit of various security controls. This approach is ethically sound, as it aims to protect the organization's assets and data by addressing the most significant threats first, thereby fulfilling the duty of care to stakeholders. It also supports regulatory compliance by demonstrating a structured and documented process for managing security risks. Incorrect approach is analysis. Implementing all suggested security enhancements immediately without a prior risk assessment is professionally unacceptable because it represents a reactive and potentially inefficient use of resources. It fails to prioritize based on actual threat levels and impact, leading to unnecessary expenditure and complexity. This approach can also introduce operational instability by deploying unvetted controls, potentially creating new vulnerabilities. From a regulatory and ethical standpoint, it demonstrates a lack of due diligence in understanding the true risk landscape and may not satisfy requirements for cost-effective risk management. Focusing solely on the most technically complex security solutions, irrespective of their direct relevance to the identified threats, is also professionally unsound. This approach often stems from a desire to showcase advanced technical capabilities rather than addressing the core security concerns. It can lead to over-engineering, increased operational overhead, and a false sense of security if the implemented solutions do not directly mitigate the most probable or impactful risks. Ethically, it can be seen as a misallocation of resources that could have been better used to address more pressing security needs. Ignoring stakeholder feedback entirely and proceeding with a design based solely on technical preferences is a critical professional and ethical failure. Stakeholder input, especially regarding security concerns, is vital for a successful network design that meets business objectives. Disregarding this feedback can lead to a design that is not aligned with the organization's risk appetite or compliance obligations, potentially exposing the organization to significant liabilities. It demonstrates a lack of collaboration and understanding of the business context, which are fundamental to professional network design. Professional reasoning. Professionals should adopt a structured risk management framework. This involves 1. Identifying all potential threats and vulnerabilities relevant to the enterprise network. 2. Assessing the likelihood of each threat occurring and the potential impact on the business. 3. Prioritizing risks based on this assessment. 4. Developing and evaluating mitigation strategies, considering their effectiveness, cost, and operational impact. 5. Implementing the chosen strategies and continuously monitoring their effectiveness. This iterative process ensures that security measures are proportionate to the risks and aligned with business objectives and regulatory requirements. Question 9. The monitoring system demonstrates an unusual spike in traffic patterns originating from an internal server, flagged as a potential low-severity security anomaly. The traffic appears to be directed towards an external, unapproved cloud storage service, but the data payload is encrypted, and the volume is not immediately indicative of a large-scale exfiltration event. What is the most appropriate immediate course of action for the network design and security team? Option A. Escalate the alert to senior management for a decision on whether to investigate further, given the low severity and encrypted nature of the traffic. Option B. Implement an immediate patch for the server's operating system and all related applications, assuming the anomaly is due to a known, unpatched vulnerability. Option C. Initiate a full forensic investigation to determine the nature of the data being transferred and the exact vulnerability exploited, while temporarily isolating the affected server from the network to prevent further unauthorized activity. Option D. Immediately block all outbound traffic to the identified external cloud storage service at the firewall to prevent any potential data exfiltration, and notify all affected customers of a potential data breach. Correct answer is C. Initiate a full forensic investigation to determine the nature of the data being transferred and the exact vulnerability exploited, while temporarily isolating the affected server from the network to prevent further unauthorized activity. Explanation: the monitoring system demonstrates a potential security vulnerability that could impact the confidentiality and integrity of sensitive customer data. The challenge lies in balancing the immediate need to address the vulnerability with the ethical and regulatory obligations concerning data privacy and notification. The correct approach represents best professional practice because it prioritizes a thorough, controlled investigation before any external communication. This ensures that the scope and impact of the vulnerability are accurately understood, preventing premature or inaccurate disclosures that could cause undue alarm or damage to the organization's reputation. Adhering to established incident response protocols, which typically involve internal assessment, containment, eradication, and recovery, is crucial. This methodical process aligns with the principles of responsible disclosure and minimizes the risk of further compromise. Furthermore, it allows for the development of a clear, factual communication plan that meets any legal or contractual notification requirements without speculation. An incorrect approach that involves immediate public disclosure without proper investigation is ethically and regulatorily unsound. This premature action could violate data privacy regulations by disclosing information about a vulnerability before its actual impact on specific data is confirmed, potentially leading to unnecessary panic among customers and stakeholders. It also fails to uphold the principle of minimizing harm, as an unverified disclosure might alert malicious actors to a weakness before it can be fully mitigated. Another incorrect approach, which is to ignore the alert due to its low severity rating, is a significant ethical and regulatory failure. Even low-severity alerts can indicate a potential pathway for more sophisticated attacks or could be part of a larger, more critical issue. Ignoring such alerts demonstrates a lack of due diligence and a disregard for the organization's responsibility to protect data, potentially violating data protection laws and failing to meet the standard of care expected in network security design and operation. A further incorrect approach, which is to immediately patch the system without understanding the root cause or potential side effects, carries its own risks. While patching is often necessary, a hasty, unanalyzed patch could introduce new vulnerabilities, disrupt critical services, or fail to address the underlying issue, leading to a recurrence of the problem. This approach lacks the systematic problem-solving required for robust network design and security, potentially leading to further incidents and regulatory scrutiny for failing to implement effective controls. The professional decision-making process for similar situations should involve a structured incident response framework. This framework typically includes preparation, identification, containment, eradication, recovery, and lessons learned. When an alert is received, the first step is to identify the nature and scope of the potential issue. This is followed by containment to prevent further damage, then eradication of the threat, and finally, recovery of affected systems. Throughout this process, communication, both internal and external, if required by regulations or policy, must be carefully managed based on verified facts. Ethical considerations, such as data privacy and stakeholder trust, must guide every decision. Question 10. Investigation of a network design proposal reveals that a proposed change, intended to enhance network performance, inadvertently masks a pre-existing security vulnerability. The network engineer is under pressure to deliver the performance upgrade quickly and is concerned that highlighting the vulnerability might reflect poorly on their previous design work. What is the most ethically sound and professionally responsible course of action? Option A. Implement the design change and then create documentation that emphasizes the performance gains while omitting any mention of the underlying security vulnerability. Option B. Implement the design change, clearly documenting the performance benefits and also transparently detailing the security vulnerability that the change helps to mitigate, along with any residual risks and proposed further remediation steps. Option C. Implement the design change without mentioning the security vulnerability, focusing solely on the performance improvements to meet the immediate stakeholder demand. Option D. Delay the design change until a separate project can be initiated to address the security vulnerability, even though this will postpone the desired performance improvements. The correct answer is B. Implement the design change, clearly documenting the performance benefits and also transparently detailing the security vulnerability that the change helps to mitigate, along with any residual risks and proposed further remediation steps. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the ethical obligation to maintain data integrity and avoid misrepresentation, particularly when network design decisions have potential security implications. The network engineer is faced with a conflict between a perceived immediate need for network performance improvement and the ethical responsibility to accurately document and justify design choices, especially when those choices might obscure or mitigate existing vulnerabilities. The pressure to deliver a solution quickly, coupled with the desire to avoid admitting a prior oversight, creates a complex ethical landscape. Careful judgment is required to balance stakeholder expectations with professional integrity and adherence to industry best practices. Correct approach analysis. The correct approach involves transparently documenting the security implications of the proposed design change, even if it means highlighting a pre-existing vulnerability. This aligns with the Cisco ENDESIGN exam's emphasis on designing secure and resilient networks. Best professional practice dictates that network engineers must prioritize accuracy, honesty, and the overall security posture of the network. By clearly articulating the security risks and proposing mitigation strategies, the engineer upholds their professional responsibility to inform stakeholders and make informed decisions. This approach fosters trust and ensures that security is an integral part of the design process, not an afterthought. Adherence to ethical codes of conduct for IT professionals, which often mandate honesty and competence, is paramount. Incorrect approaches analysis. One incorrect approach involves deliberately omitting or downplaying the security implications of the design change to avoid admitting a prior oversight. This is a direct violation of ethical principles related to honesty and professional integrity. It misrepresents the network's security posture and can lead to future security breaches if the underlying vulnerability is not addressed. This approach also fails to meet the design requirements of the ENDESIGN exam, which stresses security as a fundamental component of network design. Another incorrect approach is to implement the design change without any documentation or justification, hoping that the performance improvement will overshadow any potential security concerns. This demonstrates a lack of professional diligence and accountability. It leaves the network in an undocumented and potentially insecure state, making troubleshooting and future modifications difficult and risky. This also violates the principle of thorough design documentation, a key aspect of professional network engineering. A third incorrect approach is to implement the design change and then retroactively create documentation that falsely portrays the change as solely performance-driven, ignoring any security benefits or implications. This constitutes professional misconduct and deception. It undermines the credibility of the engineer and the design process, and it can have severe consequences if the misrepresentation is discovered, potentially leading to disciplinary action and damage to professional reputation. Professional reasoning. Professionals should approach such situations by first identifying the core ethical obligations, honesty, competence, and the duty to protect the integrity and security of the systems they design and manage. The decision-making process should involve 1. Thoroughly analyzing the proposed design change and its full impact, including performance, security, and operational aspects. 2. Consulting relevant professional codes of conduct and ethical guidelines. 3. Communicating findings transparently and objectively to stakeholders, presenting both the benefits and the risks. 4. Proposing solutions that address all aspects of the design, including security vulnerabilities. 5. Documenting all decisions and justifications accurately and comprehensively. If faced with pressure to compromise ethical standards, professionals should be prepared to articulate the rationale for their adherence to best practices and ethical principles, seeking guidance from senior colleagues or ethics committees if necessary. Question 11. Governance review demonstrates that a significant number of remote access VPN connections are bypassing the mandated multi-factor authentication (MFA) controls, leading to potential unauthorized access. The network design team is tasked with addressing this immediate security gap while ensuring minimal disruption to remote users who rely on consistent access for critical business functions. What is the most appropriate design approach to rectify this situation and prevent future occurrences? Option A. Implement a strict enforcement policy on the VPN concentrator that immediately terminates any session not authenticated via MFA, coupled with a communication campaign to educate users on the new requirements and provide support for MFA enrollment. Option B. Update the VPN client software on all remote devices to automatically enforce MFA at the point of connection, disabling the ability for users to bypass the prompt. Option C. Deploy additional network segmentation to isolate the non-MFA authenticated VPN traffic, creating a less secure zone for these connections, while the organization investigates a long-term solution. Option D. Revert the VPN configuration to a simpler, less secure authentication method that is known to be more user-friendly and less prone to bypass, prioritizing immediate connectivity for all users. The correct answer is A. Implement a strict enforcement policy on the VPN concentrator that immediately terminates any session not authenticated via MFA, coupled with a communication campaign to educate users on the new requirements and provide support for MFA enrollment. Explanation. Scenario analysis. The scenario presents a common challenge in enterprise network design, balancing the need for robust security with the practicalities of rapid deployment and user accessibility. The governance review highlights a potential gap between established security policies and the actual implementation, creating a risk of non-compliance and security vulnerabilities. The professional challenge lies in identifying the root cause of this discrepancy and proposing a solution that is both technically sound and adheres to the organization's security posture, without introducing new risks or significantly delaying critical business operations. The pressure to deliver quickly can often lead to shortcuts that undermine long-term security objectives. Correct approach analysis. The correct approach involves a thorough assessment of the existing network infrastructure and the specific security controls that are being bypassed or inadequately implemented. This includes understanding the reasons behind the bypasses. Are they due to misconfiguration, lack of awareness, or deliberate circumvention? By engaging with stakeholders, including security teams and end users, and analyzing network traffic and logs, the designer can pinpoint the exact areas of non-compliance. The subsequent design must then incorporate security controls that are both effective and user-friendly, potentially through policy refinement, automated enforcement mechanisms, or targeted training. This approach aligns with the principles of secure network design, emphasizing a proactive and integrated security posture rather than a reactive fix. It upholds the organization's commitment to security policies and regulatory compliance by addressing the underlying issues and building security into the network architecture from the ground up. Incorrect approaches analysis. Implementing a blanket security policy enforcement without understanding the context of the bypasses is an incorrect approach. This could lead to legitimate user traffic being blocked, impacting productivity, and potentially leading to further workarounds that create new security risks. It fails to address the root cause and can create user friction. Ignoring the governance review findings and proceeding with the existing, non-compliant implementation is a severe regulatory and ethical failure. This demonstrates a disregard for established policies and a willingness to operate in a non-compliant state, exposing the organization to significant security breaches and potential legal ramifications. It undermines the principle of accountability in network design. Focusing solely on technical remediation of the bypass controls without considering the user experience or the underlying reasons for the bypass is also an incomplete approach. While technically sound, it may not be sustainable if users find the new controls overly restrictive or difficult to use, leading to further attempts to circumvent them. This approach misses the opportunity to foster a culture of security awareness and collaboration. Professional reasoning. Professionals should approach such situations by first prioritizing a comprehensive understanding of the problem. This involves gathering data, consulting with relevant teams, and analyzing the impact of any proposed changes. The decision-making process should be guided by a risk-based methodology, weighing the security benefits against potential operational impacts. Transparency with stakeholders and a commitment to iterative improvement are crucial. When faced with a governance review highlighting noncompliance, the professional's duty is to investigate, propose solutions that align with policy and best practices, and ensure that security is an integral part of the network design, not an afterthought. Question 12. When evaluating the design of a new enterprise network for a financial services firm that handles sensitive customer data and is subject to strict data privacy regulations, which approach best balances security, operational efficiency, and regulatory compliance? Option A. Implement a comprehensive suite of security controls across all network segments from day one. prioritizing the most stringent security policies to mitigate all potential threats, even if it introduces significant operational overhead and initial deployment delays. Option B. Conduct a thorough risk assessment to identify critical assets and potential threats, design security controls in a phased manner based on risk prioritization, and establish a continuous monitoring and adaptation strategy to ensure ongoing alignment with business needs and regulatory requirements. Option C. Deploy the network with minimal security configurations to ensure maximum accessibility for all users and devices, relying on endpoint security solutions to manage individual device risks and address network-level security concerns as they arise. Option D. Design the network with a focus on rapid deployment and scalability, incorporating basic security measures and planning to address more advanced security requirements and regulatory audits in subsequent phases after the network is fully operational. The correct answer is A. Implement a comprehensive suite of security controls across all network segments from day one, prioritizing the most stringent security policies to mitigate all potential threats, even if it introduces significant operational overhead and initial deployment delays. Explanation. This scenario presents a common challenge in enterprise network design, balancing the need for robust security with the operational requirements of a rapidly evolving business. The professional challenge lies in interpreting and applying security, best practices, and regulatory guidelines within the context of a dynamic business environment where agility is paramount. A hasty or overly restrictive security posture can stifle innovation and productivity, while an inadequate one can expose the organization to significant risks, including data breaches, compliance violations, and reputational damage. Careful judgment is required to ensure that security measures are effective, proportionate, and aligned with business objectives, all while adhering to relevant frameworks. The correct approach, which involves a phased implementation of security controls informed by a thorough risk assessment and ongoing monitoring, represents best professional practice. This methodology ensures that security investments are prioritized based on actual threats and vulnerabilities, minimizing disruption to business operations. It aligns with the principles of defense in depth and continuous improvement, which are fundamental to modern cybersecurity. Furthermore, this approach facilitates compliance with regulatory frameworks by demonstrating a proactive and systematic effort to protect sensitive data and systems. By integrating security into the network lifecycle from the outset and maintaining vigilance, organizations can build a resilient and secure enterprise network. An incorrect approach that prioritizes immediate, broad-stroke security measures without a nuanced understanding of the business impact fails to meet professional standards. Such an approach can lead to over-provisioning of security, creating unnecessary complexity and cost, or conversely, overlooking critical vulnerabilities due to a lack of targeted analysis. This can result in a network that is both insecure and inefficient. Another incorrect approach, which defers security considerations until after the network is deployed, is ethically and regulatorily unsound. This reactive stance significantly increases the risk of breaches and noncompliance, as security is treated as an afterthought rather than an integral component of the design. It demonstrates a failure to uphold the professional responsibility to protect organizational assets and data. The professional decision-making process for similar situations should involve a structured risk management framework. This includes identifying assets and their criticality, assessing potential threats and vulnerabilities, evaluating the likelihood and impact of security incidents, and then selecting and implementing appropriate security controls. Continuous monitoring, regular review of security policies, and adaptation to evolving threats and business needs are crucial. Professionals must also stay abreast of relevant regulatory requirements and industry best practices to ensure that their designs are not only technically sound, but also compliant and ethically responsible. Question 13. The control framework reveals a significant deficiency in the enterprise network's approach to identifying and prioritizing potential security threats. Which of the following methodologies best represents a robust and compliant risk assessment strategy for designing secure enterprise networks? Option A. Focusing on the implementation of security controls that are the easiest and quickest to deploy, regardless of their direct correlation to identified high-priority risks. Option B. conducting a comprehensive threat modeling exercise that maps potential attack vectors to critical assets, followed by an impact analysis to quantify the business consequences of successful exploitation, and then prioritizing mitigation efforts based on a combination of likelihood and impact. Option C. Implementing a broad suite of advanced security technologies and solutions that are widely recognized as industry-leading, assuming they will cover all potential threats. Option D. Relying on a review of security advisories and news articles related to common network vulnerabilities, and then applying generic security best practices without specific analysis of the enterprise's unique environment. The correct answer is B. Conducting a comprehensive threat modeling exercise that maps potential attack vectors to critical assets, followed by an impact analysis to quantify the business consequences of successful exploitation, and then prioritizing mitigation efforts based on a combination of likelihood and impact. Explanation. The control framework reveals a critical gap in the enterprise network's risk assessment process, specifically concerning the identification and mitigation of potential threats to data integrity and availability. This scenario is professionally challenging because a flawed risk assessment can lead to misallocation of resources, ineffective security controls, and ultimately, significant business disruption and potential regulatory noncompliance. The pressure to implement solutions quickly without a thorough understanding of the actual risks can exacerbate these issues. The correct approach involves a systematic and comprehensive risk assessment methodology that prioritizes threats based on their likelihood and potential impact on business operations and sensitive data. This aligns with best professional practices in network design and security, which mandate a proactive and evidence-based approach to risk management. By identifying specific vulnerabilities and the threats that exploit them, and then evaluating the potential business impact, network designers can implement proportionate and effective controls. This ensures that security investments are targeted where they are most needed, maximizing return on investment and minimizing residual risk to an acceptable level, thereby adhering to the spirit of regulatory frameworks that demand due diligence in protecting information assets. An incorrect approach that focuses solely on implementing the latest security technologies without a preceding risk assessment is professionally unacceptable. This represents a failure to understand the specific threat landscape and the organization's unique vulnerabilities, leading to a solution in search of a problem. It can result in wasted expenditure on controls that do not address the most significant risks, leaving critical areas unprotected. Ethically and regulatorily, this demonstrates a lack of due diligence and a failure to exercise professional judgment in safeguarding the enterprise's information assets. Another incorrect approach that relies on anecdotal evidence or the security posture of peer organizations without conducting an independent assessment is also professionally unsound. While industry best practices are valuable, they do not substitute for a tailored risk assessment that considers the specific context, architecture, and threat environment of the enterprise. This approach risks overlooking unique vulnerabilities or misinterpreting the relevance of external threat intelligence, potentially leading to inadequate security measures. It can be seen as a regulatory failure to adequately understand and manage the specific risks faced by the organization. Finally, an approach that prioritizes perceived ease of implementation over the actual risk reduction achieved is a significant professional failing. This often stems from a desire for quick wins or a lack of understanding of the long-term implications of security decisions. It can lead to the deployment of superficial controls that do not effectively mitigate the identified risks, leaving the organization exposed. This demonstrates a lack of commitment to robust security and can be interpreted as a breach of professional responsibility to protect the enterprise's interests. The professional decision-making process for similar situations should involve a structured risk assessment framework. This includes asset identification, threat identification, vulnerability assessment, likelihood and impact analysis, risk evaluation, and treatment planning. Professionals must critically evaluate the evidence, consider the business context, and prioritize actions based on a clear understanding of the risks. They should also maintain an awareness of relevant regulatory requirements and ethical obligations to ensure that their network designs and security strategies are both effective and compliant. Question 14. Risk assessment procedures indicate that a critical enterprise application handling sensitive customer data is vulnerable to sophisticated network-based threats, potentially leading to data exfiltration and service disruption. The network design must incorporate security measures that mitigate these risks without introducing unacceptable latency that would impact application performance and user experience, while adhering to U.S. regulatory compliance standards. Which of the following network security design approaches best addresses these requirements? Option A. Enhance endpoint security solutions across all user devices and servers connected to the network. Option B. Configure granular access control lists (ACL) on existing core network routers to filter traffic based on source and destination IP addresses. Option C. Implement a software-based firewall solution on a general-purpose server positioned at the application's network ingress point. Option D. Deploy a dedicated, high-performance security appliance with integrated network acceleration and advanced threat detection capabilities. The correct answer is D. Deploy a dedicated, high-performance security appliance with integrated network acceleration and advanced threat detection capabilities. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise network design, where a critical business application's availability is directly tied to network performance and security. The challenge lies in balancing the need for robust security controls with the imperative to maintain application responsiveness and user experience, especially when dealing with sensitive data. The risk assessment has identified potential threats, but the design team must translate these risks into actionable network security and performance strategies without introducing unacceptable latency or complexity. The professional challenge is to select the most effective and compliant method for mitigating identified risks within the constraints of the Cisco ENDESIGN framework and applicable U.S. regulations. Correct approach analysis. Implementing a dedicated, hardware-based security appliance with integrated network acceleration features represents best professional practice. This approach aligns with U.S. regulatory frameworks such as HIPAA for healthcare data or PCI DSS for payment card data, which mandate strong security controls and data protection. Such appliances are designed to handle high volumes of traffic, perform deep packet inspection, and enforce security policies with minimal impact on application latency. This directly addresses the risk assessment findings by providing a robust, scalable, and compliant solution that prioritizes both security and performance for the critical application. It demonstrates a proactive and integrated approach to risk management, ensuring that security measures do not become a bottleneck for essential business operations. Incorrect approaches analysis. Deploying a software-based firewall on a general-purpose server introduces significant regulatory and ethical failures. Software firewalls can be resource-intensive, leading to performance degradation and increased latency for the critical application, potentially violating service-level agreements, SLAs, and compliance requirements that mandate application availability and responsiveness. Furthermore, relying on a general-purpose server for security functions can create a single point of failure and may not meet the stringent security hardening and operational requirements mandated by U.S. regulations for handling sensitive data. Implementing a simpler, less granular access control list (ACL) configuration on existing network devices is also professionally unacceptable. It might offer some basic protection. It fails to adequately address the specific, identified risks of sophisticated threats and data exfiltration. U.S. regulations often require more than just basic access control. They demand comprehensive security measures, including intrusion detection/prevention, and advanced threat mitigation. An ACL alone is unlikely to provide the necessary depth of security or the performance characteristics required for a critical application, leading to potential compliance violations and increased vulnerability. Relying solely on endpoint security solutions without addressing network-level threats is another failure. Endpoint security is crucial, but it is not a substitute for network-level defenses. Sophisticated network-based attacks can bypass endpoint security. U.S. regulations emphasize a layered security approach, and neglecting network-level controls leaves the critical application exposed to a wide range of threats that could lead to data breaches and significant financial and reputational damage, violating the principle of due diligence in protecting sensitive information. Professional reasoning. Professionals should approach this by first thoroughly understanding the specific risks identified in the assessment and their potential impact on the critical application and sensitive data. This understanding should then be mapped against the requirements of relevant U.S. regulations, e.g., NIST Cybersecurity Framework, specific industry regulations. The design process should prioritize solutions that offer a balance of security, performance, and scalability, while also considering operational manageability and cost-effectiveness. A phased approach, starting with a robust network security architecture that integrates with application requirements, is often prudent. Continuous monitoring and periodic reassessment of risks and the effectiveness of implemented controls are essential to maintain compliance and adapt to evolving threat landscapes. Question 15. Strategic planning requires a comprehensive evaluation of network design implications when a U.S.-based company is establishing a new branch office in the United States, specifically concerning data handling and privacy. Which of the following approaches best ensures compliance with relevant U.S. federal and state regulations? Option A. Prioritizing the lowest cost network hardware and software solutions that provide basic connectivity and security features, with the understanding that compliance can be retrofitted later if necessary. Option B. Conducting a detailed review of applicable U.S. federal and state data privacy laws, e.g., HIPAA, CCPA, and designing the network infrastructure and policies to proactively meet or exceed these specific requirements, including data localization and access controls. Option C. Designing the network to meet general industry security best practices, with a focus on performance and scalability, and addressing specific U.S. regulatory requirements only if explicitly identified as a critical issue during deployment. Option D. Implementing the same network security and data handling policies that have been successfully used at the company's existing international locations, assuming they represent a high standard of practice. Correct answer is D. Implementing the same network security and data handling policies that have been successfully used at the company's existing international locations, assuming they represent a high standard of practice. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise network design, where a company is expanding its operations into a new geographical region. Primary professional challenge lies in ensuring that the network design not only meets the functional requirements of the business, but also adheres to the specific legal and regulatory landscape of the target country. Failure to do so can lead to significant legal penalties, operational disruptions, and reputational damage. The need for careful judgment arises from balancing business needs with compliance obligations, which can sometimes appear to be in conflict. Correct approach analysis. The correct approach involves a thorough understanding and application of the specific regulatory framework governing data privacy and network operations in the target country. For the purpose of this exam, we assume the jurisdiction is the United States. In the U.S., this would involve consulting relevant legislation such as the Health Insurance Portability and Accountability Act, HIPAA, if dealing with health information, the Children's Online Privacy Protection Act, COPPA, for data related to children, or the California Consumer Privacy Act, CCPA, for consumer data in California, among others. A network design that proactively incorporates data localization requirements, encryption standards mandated by U.S. law, and access control policies aligned with U.S. privacy regulations represents best professional practice. This demonstrates due diligence and a commitment to legal and ethical operation. Incorrect approaches analysis. One incorrect approach would be to assume that the network design and security policies used in the company's existing region are universally applicable and sufficient for the new U.S.-based operations. This ignores the distinct legal and regulatory requirements of the United States, potentially leading to violations of data privacy laws like HIPAA or CCPA, resulting in substantial fines and legal action. Another incorrect approach would be to prioritize cost savings by implementing a network infrastructure that does not meet the specific security and data handling standards mandated by U.S. regulations, even if it appears functionally adequate. This could lead to vulnerabilities that expose sensitive data, violating U.S. privacy laws, and exposing the company to significant legal and financial repercussions. A third incorrect approach would be to implement a network design based on general industry best practices without verifying their alignment with specific U.S. federal and state laws. While general best practices are important, they are not a substitute for understanding and adhering to legally mandated requirements. This could result in a network that is technically sound but non-compliant, leading to regulatory nonconformance. Professional reasoning professionals designing enterprise networks must adopt a risk-based and compliance-driven approach. This involves 1. Identifying all relevant legal and regulatory frameworks applicable to the target jurisdiction. 2. Conducting a thorough gap analysis between existing designs/policies and the new regulatory requirements. 3. Prioritizing compliance in all design decisions, integrating security and privacy controls from the outset. 4. Seeking legal counsel or expert advice on regulatory matters when uncertainty exists. 5. Documenting all compliance-related decisions and justifications. This systematic process ensures that the network design is not only functional and efficient, but also legally sound and ethically responsible. Question 16. The assessment process reveals that a newly deployed enterprise network, designed with extensive VLAN segmentation and multi-vendor wireless access points, is experiencing intermittent and unpredictable performance degradation, impacting critical business applications. Users report slow response times and occasional connection drops. The network operations team is under pressure to restore optimal performance immediately. Which of the following troubleshooting approaches is the most professionally sound and effective for identifying the root cause? Option A. Immediately focus on reconfiguring the wireless controller settings and adjusting quality of service (QoS) parameters on the core switches, as wireless performance is often the primary bottleneck in enterprise networks. Option B. Begin by systematically verifying the physical and data link layer connectivity and status across the affected network segments, then progressively move up the OSI model to diagnose network, transport, and application layer issues. Option C. Implement a broad set of security policy updates across all network segments to mitigate any potential unauthorized traffic that might be consuming bandwidth. Option D. Rely on user reports and anecdotal evidence to pinpoint the specific applications or users experiencing the most severe issues, and then investigate those areas in detail. The correct answer is B. Begin by systematically verifying the physical and data link layer connectivity and status across the affected network segments, then progressively move up the OSI model to diagnose network, transport, and application layer issues. Explanation. Scenario analysis. The assessment process reveals a critical implementation challenge where a newly deployed enterprise network exhibits intermittent performance degradation affecting key business applications. The challenge lies in isolating the root cause within a complex, multi-vendor environment that includes both wired and wireless components, and where network segmentation is a primary design consideration for security and performance. The pressure to restore full functionality quickly, coupled with the potential impact on business operations and customer trust, necessitates a systematic and evidence-based troubleshooting approach. The professional challenge is to move beyond assumptions and apply rigorous diagnostic methodologies to identify the specific network segment or component responsible for the degradation, while adhering to established network design principles and operational best practices. Correct approach analysis. The correct approach involves a methodical, layered troubleshooting methodology that begins by verifying the physical and data link layers and progresses through network and transport layers, and finally examines application layer issues. This aligns with the fundamental principles of network design and troubleshooting, ensuring that basic connectivity and operational integrity are confirmed before investigating more complex issues. Specifically, starting with physical layer checks, cabling, port status, power, and data link layer diagnostics, VLAN, MAC addresses, interface errors is crucial. This systematic progression ensures that underlying infrastructure problems are ruled out, preventing wasted effort on higher-level issues. This approach is best professional practice because it is efficient, reduces the likelihood of misdiagnosis, and is universally applicable across different network technologies and vendors, reflecting the principles of robust enterprise network design. It also implicitly supports the principle of least privilege and network segmentation by ensuring that issues are contained and diagnosed within their relevant network segments. Incorrect approaches analysis. One incorrect approach would be to immediately focus on application-level configurations or security policies without first verifying the underlying network infrastructure. This fails to adhere to the layered model of network troubleshooting and can lead to significant time loss and misdiagnosis. Ethically, it could be seen as unprofessional to bypass fundamental checks that could quickly identify a simpler, infrastructure-related problem, potentially delaying critical business operations. This approach also risks misattributing performance issues to application logic when the actual cause is network congestion or a faulty link. Another incorrect approach would be to randomly reconfigure network devices or implement broad security policy changes across the entire network in an attempt to fix the problem. This is a highly disruptive and unprofessional method that violates the principle of controlled change management, a cornerstone of enterprise network design and operations. Such actions could exacerbate the problem, introduce new issues, and have severe regulatory implications if they lead to unauthorized access or data breaches due to misconfigured security settings. It demonstrates a lack of systematic problem solving and a disregard for the potential impact on network stability and security. A third incorrect approach would be to rely solely on anecdotal evidence or the opinions of individual users without collecting objective network performance data. While user feedback is valuable, it is not a substitute for empirical data. This approach lacks the rigor required for professional network troubleshooting and can lead to incorrect conclusions. It fails to meet the professional standard of evidence-based decision-making and could result in implementing solutions that do not address the actual root cause, potentially leading to repeated issues and a loss of confidence in the IT department. Professional reasoning. Professionals should employ a structured, data-driven troubleshooting framework. This involves 1. Clearly defining the problem and its impact. 2. Formulating hypotheses based on the symptoms. 3. Systematically testing hypotheses using appropriate diagnostic tools and methodologies, starting from the lowest network layers. 4. Documenting all findings and actions taken. 5. Verifying the resolution and implementing preventative measures. This process ensures that solutions are effective, efficient, and minimize disruption, upholding professional standards and ensuring network reliability and security. Question 17. The risk matrix shows a high likelihood of a specific type of data exfiltration attack targeting sensitive customer information due to an unpatched vulnerability in a legacy application server. The IT security team has proposed several remediation strategies, which approach best balances security, operational impact, and long-term network health. Option A. Apply a virtual patch to the legacy application server's operating system to block the specific exploit, without addressing the underlying application vulnerability. Option B. Isolate the legacy application server from the main network using a dedicated VLAN and implement strict ingress/egress filtering on the firewall, while simultaneously initiating a project to migrate or replace the legacy application. Option C. Increase the frequency of Network Intrusion Detection System (NIDS) scans for known signatures related to the attack vector, assuming this will be sufficient to detect and prevent the exfiltration. Option D. Immediately disable the legacy application server to prevent any further risk, regardless of its business criticality. Correct answer is B. Isolate the legacy application server from the main network using a dedicated VLAN and implement strict ingress/egress filtering on the firewall, while simultaneously initiating a project to migrate or replace the legacy application. Explanation. The scenario presents a common challenge in enterprise network design, balancing the need for robust security with the practicalities of operational efficiency and cost. The risk matrix, a standard tool for evaluating potential threats and their impact, highlights a critical vulnerability. The challenge lies in selecting a remediation strategy that is both effective against the identified risks and compliant with the relevant regulatory framework for enterprise networks, which in the context of the 500-490 ENDESIGN exam implicitly refers to general best practices and common industry standards that would be applicable in a US-based enterprise environment, unless otherwise specified. The need for deep analysis stems from the potential for a poorly chosen solution to introduce new vulnerabilities, incur unnecessary costs, or fail to meet compliance requirements, leading to significant business disruption or regulatory penalties. The correct approach involves a multifaceted strategy that addresses the root cause of the vulnerability while considering the overall network architecture and operational impact. This includes implementing a layered security model, leveraging existing infrastructure where feasible, and ensuring that any new solutions are scalable and manageable. Best professional practice dictates a thorough assessment of potential solutions against the identified risks, considering factors such as efficacy, cost-effectiveness, operational overhead, and long-term maintainability. The chosen solution should align with the principle of least privilege and defense in depth, ensuring that the network is resilient to a variety of threats. An incorrect approach might involve a superficial fix that only addresses the symptom rather than the cause, such as simply increasing firewall rules without understanding the underlying traffic patterns or application behavior. This could lead to a false sense of security and leave the network exposed to more sophisticated attacks. Another failure would be to implement a solution that is overly complex or resource-intensive, leading to performance degradation or increased operational costs, which indirectly impacts business operations and could be seen as a failure in responsible resource management. A third incorrect approach might be to ignore the risk matrix entirely or to prioritize a quick, inexpensive fix over a comprehensive, compliant solution, which represents a significant ethical and professional failure, potentially leading to severe security breaches and regulatory noncompliance. The professional decision-making process for similar situations should involve a systematic evaluation of risks, a thorough understanding of available technologies and their implications, and a clear alignment with business objectives and regulatory requirements. This includes engaging stakeholders, conducting pilot testing, and developing a clear implementation and monitoring plan. The focus should always be on creating a secure, reliable, and efficient network that supports the organization's goals. Question 18. System analysis indicates that a network engineering team is tasked with deploying a new, high-performance network service designed to significantly improve application response times across the enterprise. The project timeline is aggressive, and there is considerable pressure to go live quickly. The team is considering various approaches to optimize the deployment process. Which of the following approaches best balances the need for speed with the imperative of maintaining operational integrity and compliance? Option A. Deploy the new network service directly into the production environment to meet the aggressive timeline, assuming any issues will be addressed post-launch. Option B. Prioritize rapid deployment by skipping the security review and validation phase, focusing solely on functional testing to meet the deadline. Option C. Introduce the new network service without a defined rollback strategy, relying on manual intervention to revert changes if problems arise. Option D. Implement automated testing for the new service, conduct a phased rollout to a subset of users, and establish a clear, tested rollback plan before full deployment. The correct answer is D. Implement automated testing for the new service, conduct a phased rollout to a subset of users, and establish a clear, tested rollback plan before full deployment. Explanation: scenario analysis. This scenario presents a common challenge in enterprise network design, optimizing processes for efficiency and scalability while adhering to strict operational and security guidelines. The challenge lies in balancing the desire for rapid deployment and resource utilization with the need for robust change management, security validation, and compliance. Network engineers must make informed decisions that impact not only performance, but also the organization's ability to meet regulatory obligations and maintain a secure posture. The pressure to deliver quickly can sometimes lead to shortcuts that, while seemingly efficient in the short term, introduce significant risks. Correct approach analysis. The correct approach emphasizes a phased, validated, and documented deployment strategy. This aligns with best practices for process optimization in regulated environments. By incorporating automated testing, staged rollouts, and comprehensive rollback plans, the network design minimizes the risk of introducing errors or security vulnerabilities that could lead to service disruptions or compliance breaches. This methodical approach ensures that changes are thoroughly vetted before full implementation, thereby optimizing the process by reducing the likelihood of costly rework and ensuring long-term stability and adherence to established protocols. This is crucial for maintaining operational integrity and meeting the implicit requirements of continuous service availability and data protection, often mandated by regulatory frameworks. Incorrect approaches analysis. Implementing a new network service without a defined rollback strategy is a significant regulatory and ethical failure. It demonstrates a disregard for business continuity and disaster recovery principles, which are often implicitly or explicitly required by compliance standards. If the new service fails, the organization could face prolonged downtime, impacting critical operations and potentially violating service-level agreements or regulatory mandates for service availability. Deploying a new network service directly into the production environment without any form of staged rollout or pilot testing, is also professionally unacceptable. This approach bypasses essential validation steps, increasing the risk of widespread service disruption and security vulnerabilities. It shows a lack of due diligence and a failure to adhere to risk management best practices, which are fundamental to responsible network engineering and often underpin regulatory compliance. Skipping the security review and validation phase for new network service is a critical regulatory and ethical lapse. In today's threat landscape, security is paramount. Failing to integrate security considerations from the outset can lead to the introduction of exploitable vulnerabilities, data breaches, and non-compliance with data protection regulations. This demonstrates a failure to uphold the duty of care to protect organizational assets and sensitive information. Professional reasoning. Professionals should approach process optimization by first understanding the operational and regulatory context. This involves identifying critical success factors, potential risks, and compliance requirements. A structured decision-making process should include 1. Risk assessment, evaluating the potential impact of different optimization strategies on performance, security, and compliance. 2. Stakeholder consultation, engaging with relevant teams, e.g., security, operations, compliance, to gather input and ensure alignment. 3. Phased implementation, favoring approaches that allow for testing, validation, and controlled rollout. 4. Documentation and monitoring, ensuring all changes are documented and continuously monitored for effectiveness and adherence to standards. This systematic approach ensures that optimization efforts enhance efficiency without compromising security, stability, or regulatory standing. Question 19. Compliance review shows that a new enterprise network service designed for real-time customer data processing is being considered for rapid deployment. The design team has proposed implementing the service with standard network security protocols and relying on the application layer to manage data privacy. However, the specific type of customer data being processed is sensitive and subject to stringent data protection regulations within the jurisdiction. What is the most appropriate approach to ensure compliance and mitigate risks before deployment? Option A. Deploy the service immediately with existing generic security measures and address any compliance gaps identified in subsequent audits. Option B. Implement the service with basic security and assume the application layer will adequately handle all data privacy concerns. Option C. Prioritize rapid deployment and defer all data privacy and security compliance considerations until after the service is operational. Option D. Conduct a comprehensive risk assessment and implement specific security controls and data handling policies tailored to the sensitive data and relevant regulations before deployment. The correct answer is D. Conduct a comprehensive risk assessment and implement specific security controls and data handling policies tailored to the sensitive data and relevant regulations before deployment. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent conflict between rapid deployment of new network services and the imperative to maintain compliance with established security and data privacy regulations. The pressure to deliver functionality quickly can lead to shortcuts that bypass necessary security controls or data handling procedures. The network designer must balance innovation with risk management, ensuring that new deployments do not inadvertently expose sensitive data or violate regulatory mandates. This requires a proactive approach to compliance, integrating it into the design process rather than treating it as an afterthought. Correct approach analysis. The correct approach involves a thorough risk assessment and the implementation of appropriate security controls and data handling policies before the new service is deployed. This aligns with the principles of security by design and privacy by design, which are fundamental to many regulatory frameworks. By proactively identifying potential vulnerabilities and ensuring that data is handled in accordance with legal requirements, e.g., data minimization, consent, secure storage, the network designer upholds professional responsibility and regulatory adherence. This approach minimizes the likelihood of future breaches, fines, and reputational damage. It demonstrates a commitment to responsible network engineering that prioritizes both functionality and compliance. Incorrect approaches analysis. Deploying the service first and then addressing compliance issues later is a significant regulatory and ethical failure. This reactive approach creates a period of unacceptable risk where sensitive data could be compromised or regulatory violations could occur. It demonstrates a lack of foresight and a disregard for the potential consequences of non-compliance, which can include severe financial penalties and legal repercussions. Implementing the service with only basic, generic security measures without a specific assessment of the data being handled or the regulatory context is also professionally unacceptable. This approach assumes that standard security is sufficient, which is rarely the case when dealing with specific data types or regulated industries. It fails to address the nuanced requirements of data protection laws, potentially leading to violations related to data classification, access controls, or retention policies. Relying solely on the application layer to enforce data privacy, without considering the network infrastructure's role in securing data in transit and at rest, is another failure. While application-level security is crucial, the network itself provides foundational security. Neglecting network-level controls, like encryption, segmentation, and access control lists, leaves the data vulnerable at multiple points, violating the principle of defense in depth and potentially contravening regulations that mandate comprehensive data protection. Professional reasoning. Professionals should adopt a risk-based design methodology. This involves understanding the data flows, the sensitivity of the data being processed, and the applicable regulatory landscape from the outset. A structured approach to design, incorporating security and compliance requirements as integral components, is essential. This includes conducting thorough threat modeling, vulnerability assessments, and data privacy impact assessments. When faced with pressure to deploy quickly, professionals must advocate for the necessary time and resources to ensure compliance, clearly articulating the risks associated with expedited, non-compliant deployments. Ethical decision-making in this context requires prioritizing the protection of data and adherence to legal obligations over short-term expediency. Question 20. The efficiency study reveals that a proposed network segmentation strategy could significantly reduce latency and improve application performance across the enterprise. However, the study does not detail how this segmentation might impact existing data access controls or the potential for data exfiltration if misconfigured. Considering the U.S. regulatory environment that emphasizes data protection and integrity, what is the most prudent design approach? Option A. Prioritize the implementation of the segmentation strategy based on its potential to reduce operational costs, with security reviews being a secondary consideration. Option B. Deploy the segmentation strategy with minimal configuration changes, relying on existing security policies to mitigate any unforeseen risks. Option C. Conduct a thorough risk assessment and compliance review of the proposed segmentation strategy against relevant U.S. data protection and security frameworks, such as NIST guidelines, before proceeding with any implementation. Option D. Immediately implement the segmentation strategy as recommended by the study to capitalize on the performance gains, assuming that any security implications can be addressed post-implementation. The correct answer is C. Conduct a thorough risk assessment and compliance review of the proposed segmentation strategy against relevant U.S. data protection and security frameworks, such as NIST guidelines, before proceeding with any implementation. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in balancing network performance optimization with the strict adherence to established regulatory frameworks governing data handling and network design. The efficiency study's findings, while indicating a potential for improvement, necessitate a design approach that does not inadvertently create vulnerabilities or non-compliance. The core challenge lies in interpreting the study's implications within the context of the ENDESIGN exam's specified regulatory jurisdiction, which for this question is assumed to be the United States, focusing on general principles of network design and data privacy as guided by frameworks like NIST. A hasty implementation without considering these constraints could lead to significant legal, financial, and reputational repercussions. Careful judgment is required to ensure that any proposed solution is not only technically sound, but also legally defensible and ethically responsible. Correct approach analysis. The correct approach involves a thorough review of the efficiency study's findings in conjunction with the current network architecture and the applicable U.S. regulatory landscape, particularly concerning data integrity and security. This includes consulting relevant NIST, National Institute of Standards and Technology, guidelines, such as those related to network security and data protection, and ensuring any proposed changes align with the principles of least privilege and data minimization. The professional practice here is to prioritize a design that enhances efficiency without compromising security or privacy. This means validating the study's assumptions, assessing the impact of proposed changes on data flow and access controls, and documenting the rationale for any design modifications. This methodical approach ensures that the network remains compliant with U.S. data protection laws and industry best practices, thereby safeguarding sensitive information and maintaining operational integrity. Incorrect approaches analysis. Implementing the efficiency study's recommendations without a comprehensive regulatory impact assessment is a significant ethical and regulatory failure. This approach risks violating data privacy regulations, such as those that might be influenced by HIPAA, Health Insurance Portability and Accountability Act. If health data is involved, or general data protection principles that are increasingly codified in U.S. state laws, it bypasses the due diligence required to ensure that enhanced efficiency does not come at the cost of unauthorized data access or breaches. Adopting a solution based solely on the perceived technical benefits, without cross-referencing with established security frameworks like NIST, represents a failure to adhere to professional standards. This can lead to the introduction of vulnerabilities that, while not immediately apparent, could be exploited, resulting in non-compliance with security mandates and potential data compromise. Focusing exclusively on cost reduction derived from efficiency gain, without a parallel assessment of security and compliance implications, is also professionally unsound. This approach prioritizes financial outcomes over the fundamental responsibilities of protecting data and maintaining a secure network infrastructure, which is a direct contravention of ethical and regulatory obligations. Professional reasoning. Professionals tasked with network design must adopt a risk-based decision-making framework. This involves 1. Understanding the business and technical objectives, e.g., efficiency improvements. 2. Identifying all relevant regulatory and legal constraints within the specified jurisdiction, U.S. 3. Assessing the potential impact of proposed solutions against these constraints. 4. Prioritizing solutions that meet objectives while demonstrably adhering to all requirements. 5. Documenting the entire process, including risk assessments and compliance checks, to provide a clear audit trail. This structured approach ensures that technical decisions are informed by a holistic understanding of operational, legal, and ethical responsibilities.